Okay, so we're recording and we're going over Unit 1 practice test, which is part of homework number 7. And again, if you have any questions, feel free to do a private chat or you can speak into your microphone. So for number 1, you're being asked which of the following variables is quantitative. Here's what you need to do to figure out what's quantitative. Essentially, can you compute an average? So you need something that's numerical, basically, in nature, to be quantitative. So for example, the conference room for the meeting. Yes, that is numerical. But do you calculate an average of the conference room? Like, you have a conference room of 100 to 200. What's the average conference room number? Like, no one really cares for that. The division holding meeting, is it the math department? Is it the science department? Is it the administration? Is it the human resources department? That's categorical, not a number. Now, length of time of the meeting, that's quantitative. Like let's say you have like 10 meetings and you actually measure how long each meeting takes. And you realize, oh, this meeting takes like, 10 minutes, this meeting took an hour, this meeting took 2 hours. Can you find that? Can you compute a mean or average or median? Sure. That's how you can tell. That's something that's quantitative. If you can actually compute an average, it's numerical in nature. Also something you measure as well, just so you know. Like measuring the temperature, which actually is a gorgeous day today. Or measuring how much rain you get, stuff like that. So that's number 1. Number 1 is just C. Excuse me. Now, for number 2. The following some variables from a survey conducted by the U.S. Postal Service. Which of the variables is categorical? Now, categorical, you can't compute an average. Sorry, messy handwriting. You can't compute an average. So something that's not numerical or not necessarily measurable, like household income, you can find an average. Like you can say, this guy makes $100,000, this guy makes $200,000, this guy makes $50,000, this guy makes $1 million. I can average that. The age, I could average that too. Now I could categorize it, but ultimately I could say, hey, those who are under 20 years old, I call them young people. Those are 20 to 50, middle age. Those are 50 and older, they're old people. You could, but still, the age itself, I could compute a mean. The number of people living in your household, totally that's a number, right? Like I say, there's an average of like 3.5 people per household in Redwood City, or an average of 4.5 people per household in Appleton. But the county is not something you measure, right? Or it's not numerical, like, hey, San Mateo County, Santa Clara County, like now you could figure out how many people live in each county, and kind of share that number, but it's not necessarily that you can really compute an average. You don't, like, what is the average county? It doesn't make any sense, right? So that's why I'd say it's a category. Gender would be a category. Ethnicity, category. Yes or no, if you've graduated college, that's a category. Again, you can still present a number with it if you like down the road, but the answer itself is not numerical. It's verbal. Okay, so for 3, when drawing a histogram, it is important to, does someone want to chime in here what they said for 3? Or you can put it in the chat. Which of you think those are important? I like D. Yep, D is good. Thank you, Aiden, for that. Here's the thing: when you're doing a histogram, the whole point of a histogram is to investigate your data. And the way a histogram looks, and I remember, like Isabel, you asked a question that there's a histogram and a bar plot. Typically, you say bar plots more for categorical data. Histograms tend to be more for numerical data. But they're very similar though. But the bottom line is this. You know, like let's say you're looking at a range. Like let's say you're looking at average salary. Just because I just see that right there. Let's say the first range is like under $100,000, maybe 100 to 200 grand, whatever. And this is frequency, right? And maybe we're looking at average salary, like different values. Do I have to have similar number of observations in each interval? No. You know, I could have more in one interval than another. I want to investigate that. So we're not going to choose class intervals so that there's a similar number of observations in each one. No. I want to know if one interval has more than other like, does this interval have like the people who make a lot of money? Are there a lot of people in that group? I'm curious. I want to know that. Eliminate extremes. Never ever do that. Please, 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 never do that. Now, then you're being disingenuous with your data. People will not trust you. Never ever eliminate stuff. Be fully transparent with your data. Very important. If that is weird, that's okay. Maybe if you're running an experiment and you get some weird data, then you got to redo the experiment. You probably made a mistake. But if it's still something you're replicating, then you share that and you try to understand that. Or you meet with a group of people, you brainstorm, why does the data look weird? But never ever eliminate extremes. Never. Now, when you're building a model, usually we will remove certain data points, but then we make that disclaimer that, okay, I did, here's what it looked initially. So again, I'm not removing the data, but then when I build a model, I removed it to get something that's a little more general. But again, you have to be very clear about it, what you're doing. Make certain mean and median are contained in the same class interval? No, they can be different. Again, I want to know that. If they're different, then let's investigate why. But when you make a histogram, you got to make sure your axes are labeled clearly, so I understand what I'm reading. Otherwise, we're not going to send your data. So make sure, and horizontal too. So make sure it's very clear. For 4, standard deviation, remember we discussed this, it's a measure of spread. It's a measure of spread. How spread out is your data? You want the one that's smallest. So you want the one that's the least spread. Wholly B. They're all the same. No spread there. You don't have to compute it. It's just more intuitive. In the private chat, which one do you think would have the highest? So again, I'll just ask everyone, just quickly tell me what letter choice for number 4 would have the highest standard deviation. You do as a quick chat. So again, the one that has the most spread. So far, I see a couple people saying C. I would agree. I think C would have the most spread. And the reason why I say C is because those two numbers are really spread out. You have two numbers that are zeros, you have two numbers that are tens. You have that big gap in the middle. That's very spread out. A and D are probably about the same. But C has a lot of spread. When your data is really spread out, that's a high standard deviation. Remember, there's a formula that goes with that. The formula goes like this. You do x1 minus x bar squared plus x2 minus x bar squared. And you kind of just compute all that over and over again. And remember, the notes are your best friend here. All you have to do is just click on week 2, unit 1, so we have the notes there on that. And I have videos too. So if you go to our playlist, which I'll click on in just a sec, So that's also a good idea. And also the online textbook, I need to go to Canvas on my end. So my Northwestern program. It's gonna take a little while, but yeah, everything's really slow today. Come on, yeah. So remember, we calculate that over here. And if I were to actually go to updates, and click on this, and I do label it. So unit 1, lesson 2. Please click on that. Excuse me. And I do discuss that. Or pages 3 through 4, actually. I think you want to click on that one. So if you need to rewatch stuff, you totally can. Or you can go to electronic textbook. Yeah, that's not important right now. And if you go to, I mean, obviously it looks different for you guys. And modules. And my textbook. And you could just sort of read and click on it, and you'll be able to find it. So, and that's I think in chapter 3. So anyway, you have a lot of stuff there. Okay, let's keep moving. Number 5. A reporter wishes to portray baseball players as being overpaid. Which percentage should he report as average salary of major league players? Well, you could do the mean. The problem is that, like in NFL football, actually, does anyone know what the highest salary is for an NFL football? I know it's a different sport, but for an NFL football player, does anyone know what the highest salary? If you don't know sports, you'll be really blown away when you hear this number. Anyone know who's the highest paid football player?
Patrick Mahomes.
How much is he getting paid?
$500 million. It's like 504.
100% correct. His contract is worth $500 million. Yes, he's a very good quarterback. Yes, he won the Super Bowl. Yes, he's put up great numbers. I don't know if you're quite worth that much money, but the thing is that the mean is going to be heavily impacted by his salary. Because like now we have a famous alum who plays for the NFL, Ben Burke-Kirven, class of 2015. You guys think he makes $500 million? Probably makes $500,000, I think, in one season, which is still really good. But you can see there's a huge disparity there. And there's a lot of players like Ben Burke-Kirven, not many players like Patrick Mahomes. So a mean would not make sense because a mean would be heavily impacted by a very good player who makes a lot of money. So median would be a better fit. The median would be more the 50th percentile, right? Or if I had 100 football players, I want the football players right in the middle of his salary, or baseball in this case. I can't remember who's the highest paid baseball player. It might be Mike Trout, or I know back in the day, like Clayton Kershaw was getting paid $30 million for the LA Dodgers. So he's getting paid $1 million to pitch each game, which is kind of insane. So I'll go median for number 5. Now this year, we haven't done line graphs, but let's just talk about it. It's not that hard. I'm not going to assess you on line graphs because we haven't done that. But we'll just talk about it. So obviously looking at time and looking at problems per 100 vehicles, okay? And by 2 different companies, GM and Toyota. So for every 100 vehicles, how many problems are reported? So like in the year 2002, Toyota reported about 110 problems for every 100 vehicles. So for 100 vehicles, on average, every car at least had a problem. Maybe some cars had 2 or 3 problems. Or maybe some cars had no problems, but one car had 10 problems. I don't know. There's just a collective way of looking at data. What are the questions regarding it? In 2002, the number of problems per 100 vehicles was, so in 2002, GM had about 130 and Toyota had about 110 or so. So I wouldn't say it's twice as high for General Motors. 130 is not twice 110. About 20% higher for GM. Yeah. I'd say so. GM was higher, and if it took 20%, 110, it's about 22. So I like D for number 6. The other ones don't make sense. B and C are actually the same thing, just reversed, but the words. And for 7, which of the following is a true statement? The quality cars getting poor for both companies. They're actually getting better because you're having fewer problems. So I wouldn't say A. The number of problems is higher for General Motors than for Toyota each year. Yes, it was. Toyota did experience more problems per, because it's a ratio, right? It's not the number of problems, it's per 100 vehicles. So it's a ratio. So yeah, I'd say B. The difference in the number of problems per 100 vehicles between GM and Toyota was less than 30. No, sometimes it's more than 30, as you see here, in the year 2000. All the above, no. So go B. Okay, here we have a bar plot, or bar chart. Again, bar charts are more for categorical data. Like here you have 4 categories. Looks like that's what majors people had or what department they graduated from, I guess. And a large university is in 6 colleges. Most students graduate from 4 of these colleges. We only have 4 categories, so not 6. So the question here is the percent of students graduating from either engineering or business. Well, engineering had about 20%. Business had about 30%. So it's approximately 50%. It's literally that straightforward. That's all. So I'll make sure you guys can read that carefully. As you can imagine, the test is not going to be terribly hard. It's going to be pretty straightforward. So, but if there's anything you find a little challenging, please let me know and I'll work with you on it. But a lot of this is going to be pretty straightforward. 10 wave plots, I will ask that. Make sure you guys know how that works. And I do give a little key here. So 5, line 2 means 52. So to the left is a 10s digit. To the right is a 1s digit. So the first question is, what percentage of employees worked at the plant for less than 60 months? Well, first of all, I need to know how many data points I'm dealing with. 40 data points. And how many people are less than 60? So I got to focus on these people here. All you got to do is just count it. I'll take a little spotlight. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's kind of cool. I didn't know that it actually does that if you click on it. So there's 10 data points that are less than 60. So guess what? I do 10 out of 40, 0.25 or 25%. Remember, the first data point is going to be 52, then another 52, then a 53, then a 53, and so forth. And then number 10 would be, what would be a better way to represent this data set? I'm not sure about split the stems. I mean, I don't know what that means actually. A pie chart's usually better for categorical data. The data here is not categorical because you're looking at time that they worked somewhere. That's actually something you can compute an average. It's numerical. So I wouldn't go with a pie chart. Pie chart would have actually been great for this. That's categorical. But not for 10. Not for a pie chart for number 10. And a time plot, I don't know what that really means. I use a histogram. Histogram would be good. And you could do like different categories, like from 0 to 10, 10 to 20, 20 to 30. You kind of just look at all those different categories. And you kind of do these bars like that. So I'll go with the histogram. I'll go a D for 10. Any questions about these first 10 problems so far? No? Okay.
I was gonna ask something about I don't know if it's the same thing, but for I think just above question 17, it's making a stem plot.
Mm-hmm.
And like, okay, hold on.
That's great. I'm sure that's your dad.
Okay, I'll ask later. I'll ask later.
Okay, no problem. You put in the chat. How about that? Put in the chat and I'll address it. No problem. Right. That's awesome. By the way, let's just a little quick heat check to see how things are going. Excuse me, clear my throat here. What do you guys think the median will be for this? where we have 40 data points. What do you think the median would be? This is the one advantage of the stem plot. The stem plot makes it easy to find find medians. So go and put in a private chat what you think the median is, and I'll let you know in a sec. I'll give you guys about a minute to figure that out. So again, what do you think the median is for the set that we just dealt with here? Okay, a couple responses have come in so far. We got 3 responses.
Okay, the dog is gone, so I can ask now.
Yeah, fire away.
Okay, so for 17 through 19, it's just like the same kind of idea for the stem plot. And like when we had to make the actual stem plot, I looked back at the answer key and I did it a little bit differently when I was trying to create it, where I put the numbers in like the numerical order that it was, or not numerical order, but in the order that it was in on, like say like the American League, it's 039, and then on the answer key you had it as 930.
Oh, that's weird.
And I don't
didn't
know.
make that answer key, just so you know.
You didn't make the answer? Okay, so
I
I
did
didn't know why that was the case or why I needed to
should
do
keep it in
that.
numerical order. Yeah, that's weird. I don't know.
So,
Let me look at
but
it.
it wouldn't matter or change the outcome if I just put
No.
Okay.
Oh, I see why someone did it that way, just so you can easily combine. I would still put it as one. Like, I see why they did it, so you can still tell which one's which.
Okay.
That's the reason why. I'm not going to be asking that. I don't care for that. So I wouldn't worry about it.
All right.
Okay, let's see what some of you guys are saying for the median here. Looks like 4 people have offered up their responses. Hopefully you guys are all getting the same thing. So I'm seeing about 66. So the best way to do it, remember the median is the middle number. You got 40 employees. So it's going to be, what's going to be right in the middle? You got 20 to get, you got your lower 20 and your upper 20, right? So it's going to be the average of the 20th and 21st numbers. So you just count it. Take a little spotlight here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So the 20th and 21st numbers are right there. If you average that, that's 66 plus 67 divided by 2, and you get 66.5. That's all. So that's how you find the median from a assembly plot. Okay, let's keep moving. Here we have pie chart. So this is categorical data. Apparently being asked, let's see here. So they measure the gas mileage. And this is where the cars are from. Okay. Okay. So based on this pie chart, what can we conclude? It seems like most of the cars came from the USA. They don't give us numbers, but it's a bigger piece of the pie. I don't know anything about the mileage though. Gas mileage? I have no clue. There's nothing that tells me anything about it. Plus, I'm not sure if I'd really use a pie chart for that. But this is more if I'm looking at how many cars I had in my study. There's 38 cars. How many of those 38 cars came from the US? How many came from France and Germany and Italy and Japan and Sweden? So Japanese cars get lower gas. I don't know. More half the cars, yes. I like that one a lot. Swedish cars get more mileage, no. Mercedes, Okay, Mercedes, Audi, Porsche, and BMW represent a quarter of the cars tested. Well, first of all, I don't expect you to know what country these cars are from. Now, if you do know your cars, they come from Germany. Germany was not 25%, obviously. 25% would be more like this. But again, I'm not like I'm expecting you to know where these cars are from. And actually, I think some of these cars are actually manufactured in different countries now these days. But anyway, it's B. And if you want to do a bar chart that's equivalent to this, you kind of want US to represent the highest. So definitely not C. C is out. You do want US to be pretty much at least twice as much, because Japan's not quite a quarter, but US is more than half. And Japan's the second highest. So I think that's not going to work for us for A, because that's a little too close together. That's like about 7. That's about like 10. I don't think D is going to work either, because US still needs to be much higher for Japan compared to Japan. It has to be at least twice as much. I think that's going to be a little more reasonable there. And Japan was definitely higher than Germany. Germany was the third, not the second lowest. So I think that's why I would definitely go with B for this one, if you convert that pie chart to a bar chart or bar graph. Okay, at the home stretch here. Box whisker plots we've talked about. Remember, this is your median or Q2, the second quartile. This is Q1. This is Q3. This is the max, and that's the min. The interquartile range is Q3 minus Q1. That's all. Well, that's just roughly 600 minus 380 or 400. It's close enough to 200. So we'll say about 200. Easy enough. Now here, about half the students scored over 500. Yeah, I'd say so. The median's about 500, and the median's a 50th percentile. Yeah. Nobody scored an 800. Yep, nobody scored an 800. Because your max was right there. So I would say that's true. So definitely the answer is going to be D now. Finally, is it fairly symmetric? The answer is yes, because you don't see any kind of skew. Like if you did a box plot kind of like this, where most of your data is kind of over here, and you have just a few data points to kind of stretch it out to the right, that's called skew to the right. Your data is going to be kind of looking like that, especially if you did a histogram. It would kind of look like that. Where if you have something like this here, it'll say skewed to the left. And we're going to talk about that stuff in our next unit when we start going over distributions. But the bottom line is that everything's kind of nice and symmetric, so yes. So I go D. And finally, for 15, about 50% of applicants had ST row scores exceeding, well, obviously exceeding 500. So that's why I go B. 15. Okay, so hopefully those all make sense. Any questions so far? Okay, just interest of time. Let me do 16 and 17 to 19, then I'll put you guys in breakout rooms, and we can come back and talk about these other ones just a little bit. For 15, sorry, 16, which of the following is likely to have a mean that's smaller than the median? So in this case, you want a really low outlier, something that's like really far to the left. Salaries, no, because there's usually like someone who makes, like Patrick Mahomes, makes a lot of money. So I'd say no. The score of students on a very easy exam, but very few did poorly. Yes, that'd be a very low outlier. So I'd probably say B. The price of homes in a large city, there's usually like a handful of homes that are more expensive. That pushes the mean to the right. So here your mean will probably be bigger than your median. Here, your mean would also be bigger than your median. Again, for A, think of like a really good football player. For C, think of like a one pocket or one neighborhood that has just a lot of very expensive homes. At Peel did it was a very difficult exam. A lot of people did poor, except for maybe a handful. That's also the same thing. Mean would be higher than the median. So expect those kind of intuitive questions. Some more stem leaf plot stuff. The median of home runs hit through June 3rd for National League. So if you have, how many baseball teams are there? Well, they didn't tell us. I should know. I think there was 14 teams then, but anyway, just count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So you want the 7th and 8th ranked teams. So 1, 2, 3, 4, 5, 6, 7, 8. So it's an average of 48 and 53. Work that out, you should get 50.5. That'll be your median. And by the way, you could use Excel or a spreadsheet during your test, so totally fine. Hold on a sec here. Oh, computer's that kind of acting strange. No, it's doing that. Okay. Okay, let's keep moving here. Which one's the correct statement? The American League plot's fairly reasonable. I'd say so. The National League's probably skewed. Maybe. Yeah, you have some data points there. The median, but American League. Well, the American League, 1, 2, 3, 4, 5, 6, 7, 8. So here, the median is going to be about 57.5. So it is higher also. I assume probably more people using steroids. American League, they're out of time. I don't know. Actually, Barry Bonds in the National League and Mark McGwire and Sammy Sosa, but all the above. And the 19, don't worry about that one. So I am going to ask stuff about stem leaf plots and like, median or just some other information about it. I'm going to ask you to interpret box whisker plot. I'm going to ask you to interpret bar charts and pie charts, histograms. I'm going to do as well. Oh, I won't do line graphs. We haven't done that, but I mean, not hard, but I just won't do it. And then maybe some other conceptual questions as you see here. So that's going to be part of it. The other part's going to involve like computing standard deviation and like computing like range and mean and median, stuff like that. So that's kind of going on, I think, near the end here. So again, I'm not going to ask you to create these charts necessarily. I might ask you to maybe make a stem leaf plot or maybe make a quick box whisker plot. But that's what you can do by hand. I'm not going to, because we haven't quite practiced that skill in Excel yet or Google spreadsheets. So here's what we'll do now. It's 1:10, and we go till about 1:40. So we have about 30 minutes. I'm going to put you guys in breakout rooms right now. And so what I'm going to have you guys do is work on Unit 1 review questions in your breakout rooms. And I'll hop in and see how it's going. But just, this says 34 pages. It's a little misleading. You actually only have to work on, I think, the first 4 pages. Yeah, that's all. So just going to do 1 through 9. Shouldn't take more than a couple minutes per question, I think. And then you're going to see the answers on the 5th page. I'm not sure why the 6th page looks like that. Then here you see another version. It's actually the same test as above, just a different test number. So this is like for like a teacher who wants to like give different versions of a test so people don't cheat, I guess, in the classroom. But you're only doing 1 through 9, the first 4 pages. That's all you're doing. So I'll go to Schoology. You should be able to access it. And then we'll come back and we'll discuss. And maybe we'll do some of the free response questions at the end. And then we'll be done with class. So again, if you go to our folder, so our Schoology page, Unit 1 folder, week 4, Unit 1 review questions. We'll do 3 groups of 3. Again, I'll check in you guys in a few minutes to see how it's going. And again, you're just simply doing the first 4 pages, 1 through 9. All the other pages are the same thing, just the order questions are in a different order. That's all. So this is just a nice way to kind of just check in, to make sure things are going okay with all the stuff here. So let me stop sharing. I'll stop